So far we have done functions in the sense of doing one at a time. But now what we're going to do is start putting different functions together all at once. So just kind of to recap how we deal with functions, I have here a set, f of x, so this is the function name and this is the variable, and we have in it three ordered pairs. So remember, a function or a relation is simply a set of ordered pairs. So we might ask, well, what is the domain of this? And remember, domain is all the possible x values. And in this case, our domain is -3, 2, and -7. And the range is all the y values that are possible. And in this case, we have 1, 4, and 9. We'll get to this notation here in a minute. So if I took this function and I asked, well, what is the f of -3? That means, well, if x is 3, then what does y equal? And in this case, we'd say 1. And if I said, well, what's the f of -7? Well, I see from my function, -7, when x is -7, then y is 9. And sometimes we might be asked something like this: what is the f of like 4? And it's very tempting to see, oh, here's a 4 right here, but that's a y value, not an x value. And so as I look at my x values, I don't see a 4. So I would say that this is undefined because x equaling 4 is not part of my domain. This right here with the -1, that means inverse, and we'll be talking more about inverses later. But for inverses, all we're going to do is we're going to switch x and y. So if I take the inverse of this, and that's what this -1 means, it means inverse. The first order pair would be 1, -3. The second order pair would be 4, 2. And the third order pair would be 9, 7, -7. So I've done the inverse of that. All right, so right here I have h of x, and this time it's not defined by a set, it's defined by some variables. So I say, well, what is the h of 11? Now, assuming 11 is in my domain, I might say, all right, so 3 square root, x is 11, because that is what I'm finding, plus 5 plus 11. And then I simply follow the order of operations here. So this is an implied parentheses inside the radical, so I'll go ahead and do it. So I get 16. And then technically a radical is an exponent, so I will do that next. Now this is 3 times the answer, so 3 times the square root of 16 is 4. And then I'll get 12 plus 11, which is 33. Right here I asked for h of -1. And what this means, so what both of these mean is to replace x with whatever number is here. So I could write 3 square root of -1 plus 5 equals -1, or plus -1. So 3 square root, -1 plus 5 is 4. I get -1 right here. So 3 times the square root of 4 is 2. So 6 minus 1. Just following the order of operations here, and I get 5. All right, so just kind of taking a bigger look at this. Let's suppose, well, I didn't want to do that. We'll keep that function. I want to delete all that. So let's go back to this function. What if I say that the domain equals, say, 3, 2, 1? And I wanted to know, well, what's the range of that? Well, then I put in 3, I put in 2, and then I put in 1, and that gives me my range. So in this case, 3 square root, 3 plus 5 plus 3. And I do all of these. 3 square root 8 plus 3. Square root of 8 can simplify to 2 root 2. And I get 6 root 2 plus 3. And that will be the first element of my range, 6 root 2 plus 3. And then I do 2. And I'm not going to do all of these, but I'll go ahead and do that one. So 2 plus 5 plus 2. And you see I'm just putting each of them in successively. So my next element of my range is 3 root 7 plus 2. And then if I wanted to get the last one, I would put in the 1 as well. All right, so now we're ready to do some function operations. That was kind of a recap of what we should already be able to do with functions. Now what we want to be able to do is actually extend this a little bit and go, well, what if I take my two functions here and I add them? And what if I take my two functions and I subtract them? And what if I take them and I multiply them? And finally, what if I divide them? So what this means is take both my functions, and this is simply telling me what my variable is. My variable is x. If there were a's here, then this would be an a. So this means I want to take f of x. So there's f of x. And I want to add to it x plus 3, g. See, all of this was f, and all of this was g. Now, if I add those, I see that I have some like terms right here, so I go ahead and combine those. So x squared plus 6x plus 9. And that's my answer. That is what that equals. So right here, I'm subtracting. Now, I'm going to want to be careful of my signs. So I have x squared plus 5x plus 6 minus x plus 3. And here, I'm going to have to distribute this negative. So I have x squared plus 5x plus 6 minus x minus 3. And then I'll go ahead, so I distribute that, so I'll go ahead and combine like terms. I get x squared plus 4x plus 3. Done. And now this means to multiply. So I want to multiply these things. So I'm going to take f of x squared plus 5x plus 6, and I'm going to multiply it by x plus 3. Now, in order to do this multiplication, I'm going to distribute the x squared to both of these. So I'm going to get x cubed plus 3x squared. Then I'll take the 5x and I'll distribute that. So I plus 5x squared plus 15x. And then finally, I'll distribute the 6. And when I distribute the 6, I'm going to get plus 6x plus 18. And then I'll go ahead and simplify all that. So I have my x cubed plus, these are like terms, so 8x squared. These are like terms, so plus 21x, and then plus my 18. And that is what f times g of x is. Finally, dividing. I don't have a lot of room right here, so I'll do the f over g down here. So this means to divide these. Now, it's not always possible to actually do the division, but in this case, I can. So I have x plus 3 down here. I should be able to see that I can factor that. So I go ahead and I factor it, and I get x plus 3 times x plus 2 all over x plus 3. And now I see that I can cancel those because they're identical. And then I get equals x plus 2. So those are the 4 basic operations with functions. Now I'm going to go ahead and take some of these away, and I'm going to do the last one that we're going to be needing to do, which is called composition. So I'll delete this. All right, and got some left over, but that's okay. So let's go back to these, and we're going to work on what's called composition. So there's a few ways to write composition. The first way is like this, and this is red. This symbol is red, compose. And what it means to do is to put G into F. So I'm going to take G of X, and I'm going to put it into F of X, like that. Now there's another way to write this, and many textbooks do this. F of g of x. And that means basically the same thing. I am going to put g of x into f of x. So the order is somewhat confusing there. I am going to deselect that, and this goes into f. So that means this x plus 3, everywhere I see an x, it's going to go into that. So over here, let's do it. So I have an x squared, so instead I'm going to have an x plus 3 squared, because I put all of this into x, plus 5, parentheses, see I have an x right here, I'm going to put x plus 3 into there, plus 6. Now, this squared doesn't mean distribute. I don't distribute exponents. But this is what a squared means, something times itself. And now I go through and try to simplify this. So I multiply this out, and I distribute that 5, and then I combine my like terms. I have a 9 plus, this will be 21, so 30. And that is what f compose g of x is. Now I could also find g compose f of x, which could be written like this, or it could be written g f of x like that. And this means put f into g. So everywhere I see an x in g, I'm going to put f of x. So in this case, I would get all of this and put it into here. That's a little bit easier to do than the one we just did. So x squared plus 5x plus 6, then plus 3. See, it was, g of x was x plus 3, but I replaced x with all of f of x. And then I combine my like terms. And that is g compose f. That takes a little bit of practice, so we'll do another example. So here's another one. So let's try all 3 of them. So let's say, all 6 of them. So let's say I want to find f plus g of x. Let's make this one a little bit more interesting. We'll do f minus 2g of x. We'll skip the multiplication this time. We'll do f over g of x. And finally, we'll do the composition f of g of x. We'll do all of those. All right, so for this addition, I am just adding these two together. So I have 2x squared plus 5x minus 3 plus 2x minus 1, and I combine my like terms. And there's my answer. I'll do this one down here. So I have f of x, so that's 2x squared plus 5x minus 3, and then minus 2g. So I have a little extra thing there, so 2 times g. So I'll distribute this negative 2. So I get minus 4x, and I need to remember I distribute it to everything. So I get 2x squared plus x minus 1, and that is 2f minus 2g. So all I did was multiply g by times negative 2. F over g, so that's going to be 2x squared plus 5x minus 3 all over 2x minus 1. And I want to see if I can factor this. And it just so happens that I can. Going ahead and doing that. So that's how this top one factors from our factoring chapter. So these cancel, and I get equals x plus 3. All right, so this is f compose g. Now I could write it like this. These mean the same thing. And I'm putting g into f. So all of this, g of x, goes into every place that there's an x. So this equals 2 parentheses 2x minus 1 squared plus 5 times 2x minus 1 minus 3. Exponents first. So 2x minus 1 times 2x minus 1. Do not distribute this 2 and do not distribute this exponent. I'm going to go ahead and multiply that 5 out. Now I multiply this. So always deal with this little piece first before the times 2. So I get 4x squared minus 4x plus 1 plus 10x, and then I'll combine those minus 8. So I get 8x squared minus 8x plus 2 plus 10x minus 8. Then I go ahead and I combine. So 8x squared plus 2x minus 6. And there's our composition. All right, so last thing is maybe I'm composing, but then I want to evaluate. So this means I'm going to compose, but I'm going to replace x with 9. Okay, so in this, f compose g, I'm going to put 2x minus 3 into here. So this equals square root. So next would be x, so 2x minus 3. And then I have a plus 1. Now I'll simplify that, and 2x minus 2. And I'm going to evaluate x equals 9. So square root 2 times 9 minus 2. 18 minus 2. Square root 16, which is 4. Okay, right here, I am going to go ahead and do G compose f of 3. That means f is going to go into G. So that means I have square root x plus 1 and 2x minus 3. This is going into here. So I have 2 root x plus 1 minus 3. And now I'm going to replace x with 3. So I have 2 root 3 plus 1 minus 3. Square root 4. And 2 times 2 minus 3. So 4 minus 3, which is 1. And that's almost it for function operations.